G'day and welcome. This is the fourth of four videos in which I am demonstrating how to use the product rule in calculus to find derivatives. And it's all thanks to a subscriber called Chelsea who asked me to do so. So thank you, Chelsea. There are three questions in this video, and here's the first one. Now you can see that it is in fact a product of this times this. But we have a complication. We're not terribly fond of having square root signs or radicals, but we know how to handle them. And that is, we immediately write this as 2x plus 2 to the power 1/2, because that is what a square root is. It's whatever is inside, whatever the contents are, to the power of 1/2. And now we're in a position where we can find the derivative. Because we have a product of two expressions, we're going to have two parts to our product in our product rule, or in our pattern at least. We're going to find the derivative of this times this, so we're going to leave this alone. And we could put the derivative straight away, but I'm showing you the structure first. Then in the second one we leave the first bit alone and write the derivative here. The advantage of doing this first is that if we do have chains or quotients or funny things embedded inside the product, we can deal with them knowing that the overall product's taken care of. Let's go back now and fill in the bits. The derivative of x squared is 2x. Over here, the derivative of this, we have a function of a function. The derivative of this is 1/2, 2x plus 2. Reduce this by 1, and 1/2 minus 1 is minus 1/2. So that's taking care of that part of the chain. And then we multiply by the derivative of what's inside, which is just 2. Now we're rather fortunate here because 1/2 of 2 is 1. So we don't have any half just lying around to come out the front. Let's see what we've got. We have a 2 out the front. And it looks like we've got it here, but it disappears when we multiply it by 1/2. So we actually don't have a spare 2. Do we have an x? We certainly do. We have a common x in both expressions. So I'm going to take it out, because x to the power 1 is the lower power compared to that. So I've checked out the 2, I've checked out this, now check this out. That certainly appears in both, and we take the lowest power. Now remember, negative 1/2 is lower than that, so we're going to take this out. So let's see what's left. Going back to our first expression. There's no 2 here, so we leave the 2 inside. We've taken the x away, or we've divided it out. And we're dividing this into this as well. Now the indices are different, so this divided by that, we subtract the indices. 1/2 minus 1/2 is 1/2 plus 1/2, which is 1. You can even write the 1 there if you like, and you can see that that times that, we would, if we're multiplying, we would add those indices, and 1 take away 1/2 is 1/2. So it does work out. Put down the plus sign. Now remember, 1/2 times 2 is 1, so that's all taken care of. If we take the 1/2 out, the x out of x squared, we're left with an x, because x times x is x squared, and they're identical. So that's just come out totally, there's nothing left except 1, and I'm not going to put times 1, that's it. So those are gone. That gave us an x, and that's already gone out the front. Let's see what we've got. This looks a bit nicer than the previous question in the last video. 2x plus 2 to the negative 1/2. And this is going to be 4x plus 4 plus x. Now, x is nice and simple. Of these two, this is the next simplest. That's going to be 4x and x is 5x plus 4. And then this part is the most complicated, if you like, so it'll go last. So there we are, 1, 2, 3 bits, but we rearranged them a little. Left the x there, simplified that and put it there, put that there. And we would leave it at that. If you really wanted to, we could leave the x times 5x plus 4 untouched. The negative index would put this on the bottom of a fraction, and the half would make it into a square root. So you could write this that way. And that's the first of the 3 questions in this particular panel. So that's a perfectly acceptable way of writing the answer. Others might prefer it that way. I would like it that way if I was substituting x values. If I had to find another derivative or do something else, I'd probably prefer to leave it like that. But anyway, there it is. We have 2 more to go, and we'll see what they entail. Right, we're on the home stretch. Here we have a product again. So we know we're going to use the product rule to find the derivative, but we don't like radical signs. So we're going to rewrite this as a square root, of course, is a power of a half. Now that we've written it in this form, we can find the derivative. Let's put down the structure for the product rule. The derivative of this is going here, and we'll leave this alone. Then we'll leave this alone. It was pretty awful, wasn't it? Plus 1. Just didn't write that very clearly. And the derivative of that's going to go here. What's the derivative of x squared plus 1? It's 2x. That was easy. What's the derivative of this? Well, this is the one that involves the chain. So we have to have a chain rule inside a product. How do we deal with the chain? We deal with the power first. So it's times a half times x plus 1 to the power. Reduce that by 1, negative a half, times the derivative of what's inside, which is 1. Okay. What are we going to take out? I'm going to take the half out because I can see that this fraction is going to cause us problems. So if I take the half out, that will help. There's no other common number here. Is there an x? There's no x over here. Is there an x plus 1? Yes, there is, there. X plus 1 to a power. And the lower power is this one. So it's going to be x plus 1 to the negative a half. And that's all we're going to be able to take out. So let's see what we've got left. Out of this first expression, if we take a half out or divide 2 by a half, we get 4. How many halves are there in 2? 4. Or if you like, half times 4, or 4 times a half is 2. We're going to take the x out because it's not out here. So half of 4x is 2x. And this has to be divided by that, which gives us x plus 1. When we're dividing, we subtract the indices. Half minus minus a half is 1. Or if you want to check by multiplying this times this, we would add the indices, and a half and a minus a half, 1 and a minus a half gives a half. Move to this one. We've already taken the half out. We could write the 1, but it's a bit redundant because it's multiplied. And we've got an x squared plus 1, which doesn't appear here. And this is identical to that, same power, so it's come right out the front, and we would leave a 1 times 1. So let's check out a half times this, times that, times 1 if we wanted. So this equals a half x plus 1 to the negative a half. And this is going to be 4x times, oh, we're going to get a quadratic, aren't we? 4x squared plus 4x plus x squared plus 1. Now, which is most complicated or problematic, if you like? A power of a negative a half is worse than having a quadratic. So let's do the quadratic next. We're going to have 4x squared and x squared is 5x squared plus 4x plus 1. So that's that brought there, and we'll put this last. There we go. And that would be a good way to leave it if you really wanted to. I don't want to, I'll disappear off the bottom of the board if I go down, so we'll work across. We could write a vinculum, that's what we call our dividing bar. This of course goes on the top because it's a positive power. The 2 goes on the bottom because it's a half. And because this is a negative power, this goes down to the bottom as well. And because it's a power of a half, I can either write it as x plus 1 to the half or square root of x plus 1. Perfectly acceptable, debatable which is better. I use the word better in inverted commas because it depends what you want to do with it. So there we go. There's only one question left to go, and we'll see now what it entails. Well, here we go. Again, we have a radical sign, so our first reaction is to replace it with a power, an index. And a square root is a power of a half. So again, we see we have a product of two expressions, and one of them is a function of a function, so we're going to have a chain rule. This is quite straightforward, so it won't cause us any trouble. Let's find the derivative. Deal with the product first. It's going to be in 2 bits. Derivative of this times x squared minus 1. So there's the space we're going to put the derivative. For the second part, we leave the first bit alone, and we'll put the derivative of that there. Okay. We've got the product rule dealt with. Let's look at the bits now. The derivative of this involves a chain, and here we have a function of a function. Let's deal with this function first. It's a half x minus 1. Reduce that by 1. Negative half. So that's our chain, that's how that function dealt with, and now we multiply by the derivative of what's inside. And the derivative of x minus 1 is 1. That's nice, that's not so nice, but we'll see what happens. Going to the next bit, we left the first bit alone. What's the derivative of x squared minus 1? It is 2x. That is nice. Well, we have this expression and this expression. Never lose sight of where this is. Let's look for common factors. I have a half. There's no even number anywhere. We've only got a 1, so it's going to stay a half. I'm going to take that out the front. Otherwise it's going to cause us problems. Let's look at this next. Do I have that over here? Yes, I do. Which is the lowest power? That is. Negative a half is lower than a half, so I'm going to take this out. We ignore the 1, multiplying by 1 does nothing. Look at this one. Is there a corresponding thing over here? No, there's not. And the x is not corresponding, doesn't match anything over here. So that's as much as we get out. So let's see what's left. We've taken the half out. We don't have to worry about the 1. So we're left with these two. This one has come out exactly as it is. So all we're left with is this. That's easy for the first bit. I'll leave the parentheses on it. There's our plus. Now let's take these same things out of here. Now if I take a half out, If I divide 2 by a half, I get 4. And remember that we need the x as well because we haven't taken an x out. Half of 4x is 2x, so it works. Now we've got to divide this by this because we're dividing this out. And when we're dividing, we subtract the indices. Half minus a half is plus 1. There it is, to the power 1 if you like. And if you want to check that times that, we would multiplying, so we add the indices. 1 and negative a half is a half. I'm talking a lot more than I would talk to myself while doing this because I'm trying to explain the thinking, the processes. Let's expand this. X squared minus 1 and 4x squared minus 4x. Well, that's undoubtedly a quadratic, and a quadratic is a bit simpler than this with a negative a half, so I'm going to leave the half at the front and write this quadratic next. Now I've got an x squared and a 4x squared is 5x squared minus 4x minus 1 times x minus 1 to the negative half. Again, that's a good way to leave it, but you could, if you wanted, write your vinculum. The 2 is staying on the bottom. You can see the vinculums here. So we're dividing by 2, so there will be a 2 down here. This next expression is a power of 1, so it stays on the top. And this last bit, because it's a negative index, would move down to the bottom of the fraction, and the power of a half would make it a square root. Both of these are nice ways of writing the result, and it depends on your needs which one you prefer. I hope that helps. So I've just been through 4 videos, 12 questions. Thank you to Chelsea for suggesting them or asking for them. If you've enjoyed them, then please leave your comment and like the video. And if you're not already a subscriber and like what you see and would like to see more, then please subscribe. And as always, I thank you very much for watching.